All right, so in this question here, it gives you a function, u of t, that's not University of Toronto, but u of t, equals a plus b over t plus c over t squared. So what they're asking for is they're asking for the derivative. Okay, so u prime of t. Now, what is that? Well, right now, at this point, you don't know about the quotient rule or the product rule or anything like that. You just know about the power rule. So if you only know about the power rule, then what you have to do is you have to make these two into single monomial terms with no denominator. And so this one can be rewritten as, well, actually let's just rewrite the whole function over here, as a plus, and this would be b times t to the negative 1. And do you know what? You guys may have, I think maybe the problem was you're looking at a, b, c, and you're thinking those are variables as well. Those are actually numbers. Because this function is a function of t. That means that t is the only variable. So a, b, and c can be treated like numbers. So that's maybe where you're getting off track, hey? So this one is c times t to the negative 2. So if a is a number, b is a number, c is a number, then this should be fairly straightforward. So u prime of t would be, what's the derivative of a constant here? Just a. Yeah, 0. Okay. Now, if this b was a number, and I have t to the negative 1, what does the power rule say? That negative comes down in front. So this is negative b, t to the what? Negative 2. Good, you subtract 1 from there. Okay, subtract 1. And then, so plus, now this, we're going to have, I guess that negative is going to be in brackets, I guess. Okay. Plus negative 2c t to the negative 3. And don't worry about where I put the brackets there. Okay. But does everyone kind of see that now? If a, b, and c are numbers, which if you have t in here in this brackets here in the function notation, that t is the variable, and everything else would be constants. You could treat them like constants. So then u prime of t here would be negative b. Now you could write in simplified form. A lot of times in this course with this textbook in math, simplified form is variables have positive exponents. So you might see in your textbook this as the answer. Not really sure, but this is what it could look like. And that is, I guess, something to be aware of in the calculus course here, is that you might come up with a solution. You look in the back for the answer to check, and the answer may be in a slightly different form. Okay, so just be aware that you may have some further simplification to do to get it the same as the back of the book. If your answer is not immediately like the back of the book when you check, it may not be that you're wrong, it just may be that it's in a slightly different form. So, I don't know, check your solution. Is this what it has? The solution? Yeah, something like that? Okay. If you left it with negative exponents in your answer, that's fine. So right now, if you did this, negative b t to the negative 2 minus 2c t to the negative 3, if that's what you did, that's okay as well. But this would be the preferred format. Okay? All right, so here's another example where we're going to want to change this function here and get rid of the denominator. Okay, let's bring that up. Now, root x is x to the power of 1/2. So when this comes up to the numerator, that's actually going to be x to the power of negative 1/2 times x plus 1. Everyone see that? And now we don't want a product here. We want individual terms, right? We want a polynomial. That's how we work with the power rule and the sum difference rule. So we just multiply this in. But you have to remember what the rules are when you multiply variables or terms of the same base. So we add the exponents. So that's going to be x to the positive 1/2, because negative 1/2 plus 1. And then plus x to the negative 1/2 when you distribute that. Okay, has everyone got that? Good with that? So now y prime, and again the derivative is just to put a little prime symbol there. Y prime, that means this is the derivative of this function, and we just do our power rule here. And then you take 1/2 and you minus 1, you get negative 3 over 2. So simplified form probably would be, now this is something you're going to come across a lot in the course. This may be your first time with this. So obviously this negative exponent applies to this x, right? And so that's going to bring it down to the denominator where the 2 is. The 2 is in the denominator here, really, because it's a fraction. And that's also a power of 1/2 is a root. So this is what it would look like when it's all said and done. 1/2 x to the negative 1/2 is actually 1 over 2 root x. So you will see this in your textbook. I know for a fact that that's the format that they use. This is going to be minus, and this one is going to be 1 over, we got 2 in the denominator, and we have, this is going to be positive in the denominator, so we have a square root x, and then a cubed. And the cubed can be underneath the root sign, or it can be outside of the root sign. It's the same. Okay? So again, I'm not sure if the textbook in the back looks exactly like that. Again, it may have the cubed outside of the root sign, but that's exactly the same. If you take the square root of something cubed, that's the exact same as if you take the square root of something and then cube that answer. Same thing. It says 20 cubed x? Say what?
Minus, yeah, 20 cubed x. 1 over 2x. You're looking at the wrong thing. Oh.
Okay. All right, so this is the correct answer, but there was a question asked about this step right here. So basically, how do I get this positive 1/2 as an exponent? Is that what you're asking? Yeah. Okay. So when you multiply this term times this one, okay, x to the negative 1/2 times x to the 1. When you multiply two terms that have the same base, you keep the base, and then you add the exponents. Okay? You simply add the exponents. So that's x negative 1/2 plus 1, right? Or plus 2 over 2, negative 1 x to the 1/2. Okay? Does that make sense? Yep. So just remember to add exponents if the base is the same. Yes. So the final question was asked here, when do you multiply exponents? And of course, if you recall, when you have a power raised to a power like this, then you multiply these right here. So that would be just x. Because that would be 2 over 2. So that's when you multiply, if it's this situation. And this is when you add, when it's this situation. You have two terms of the same base. Okay, so there are those two questions, K and G, from 2.3. So one final question here that I'll do with you. This is from number 3. Now, this question says, find the equation of the tangent line. So we did this in chapter 1. Equation of the line. What do we need to write an equation? Well, we need the slope, and we need a point. Here's a point, and the slope can be found by finding the derivative of the equation and plugging x in, right? So basically, if this is a function of x here, what I need to find is I need to find f prime, and then the value of the slope of the derivative would be f prime of 1. Okay? So just to say that again, we need the we need the slope of the tangent line to the curve. So the expression for the slope is the derivative of the function. The actual slope at this given point would be the derivative evaluated at that point. So I need to find f prime of 1. So let's find f prime of x. So I take a look at each of these. What's that? What's the first thing I'm going to write here? What's the derivative of x cubed? It is 3x squared. Yeah, 3x. Try not to say 3x2. Try to say a little, if I can even talk. 3x squared, or 3x to the power of 2. That would be better. Minus what? 2x. Very good. Plus 1. Yeah, awesome. Okay, so that is the expression. I can find the slope of the tangent line at any point on this curve if I just put in the x value, and that'll give me the slope of the tangent line. So I want the slope of the tangent line at x equals 1, so that's what it's going to be. Whoops. Which is what? 3 minus 2 plus 1. Which is what? 2, right? Okay, so that is going to be the slope. So that's the slope, which is f prime evaluated at 1. That's the first step. You good with that? That's just the first step. No, we're not done. See, because the question says, I want the equation of the tangent line. So the first step is getting the slope. And now, it's easy now. Remember chapter 1? So y minus y1 equals m times x minus x1. Remember that? That's point slope form. Easy breezy. The point we're given, the y value is 0. The slope we just found, that's 2. X minus, and the x value is 1. So you could just say y equals 2x minus 2. That's in y equals mx plus b form. You're done. Or if you want to put it in general form, it could be 2x minus y minus 2 equals 0. And the back of your textbook might have that form as well. So is that... Do I care? No, I do not care. Nope. Y equals mx plus b is usually, I mean, that's going to be probably the easiest, but whatever. Okay, you good? So that's a few questions there from your assignment. So you can change this to x plus root 10 x to the negative 5. And then your question was?
Could you change the 10 to 10 to the power of half?
You could, but you don't have to change this to 10 to the power of 1/2. You don't really have to because we're just doing this, right? Negative 5 root 10. That's an acceptable way of writing that. And this is going to be x to the negative what? 6? When we do the power rule, is that ringing a bell? Okay. So really you could maybe simplify that to say negative 5 root 10 over x to the positive 6, but and that's going to be f prime of x. Okay. Does that look right? The question is, what about the domain? Okay, so if the question says, what's the domain? If you look at the original function, right, x can be anything. There's no problem, except for one value. What can x not? Yeah, 0. It can be positive or negative, but it can't be 0 here. So you just say the domain is, you can say all real, what you should say, no, well, see, it depends on who you're talking to. The domain, you can say XER, but x cannot equal 0. That's one way of putting it. It depends, it's like say who you're talking to. Negative infinity, right, to 0, really, in union with, remember all this? In union with 0, do you remember this? Oh, come on. Never seen that before? Okay, well, where did we learn that? Where did you guys learn that? Not in PC 30? No. Foundations 30 maybe we learned that. In Foundations 30. Yeah, you haven't seen it yet. Anyways, in union with means as well as or. This or this. Comma. Okay, whatever. But it's everything but 0. So I'm okay with this one, I guess, for now. You can say what domain can't equal. That's fine. Okay?